Okay, hi guys, it's Miss Redican here. I'm recording today's little live lesson. Let's go into present mode and watch a little bit of our video here. Again, reference table F and G we'll be using in today's lesson. And chemical elements if they were people. Okay, we're going to go on with today's lesson. Okay, solutions. The solute's the substance being dissolved, the Kool-Aid powder, the salt, the sugar. And the solvent is the substance doing the dissolving, usually water, but it could be other things, hexane, oils. Solubility is how much a solute can you dissolve at certain conditions. Rate is how fast you can dissolve your solute. To dissolve something faster, if it's a solid, crush it up. Stir it if it's a solid or a liquid. Don't stir or disturb gases. They actually come out of solution and make quite a mess. Temperature. If you want to dissolve solids, right, like sugar in your tea, make sure it's hot. But for gases, they dissolve better in colder temperatures, right? Carbon dioxide gas in your soda goes flat faster if it's warm. Also, if your fish tank gets too warm, you're not cooking your fish, you're suffocating it. The dissolved oxygen leaves the tank, so be careful. Pressure can affect gases too. The more pressure, the more gas bubbles will stay in your soda. And that's why we leave the cap on our soda. Table G talks about how much you can dissolve at a certain amount of water, 100 grams of water. These are saturated solutions, and they hold the maximum amount at a certain temperature. And that's what this graph shows us, Table G. Let's use Table G now. How many grams of NaNO3 are needed to create a saturated solution in 100 grams of water at 50 degrees? Well, it's always 100 grams of water. So let's look at the pertinent information. NaNO3 at 50 degrees. You go to the temperature first, and you go up to NaNO3, and you read it. And this is off a little bit, but it's around 116, right? There's really more over here, about 116. Unsaturated solutions could still hold more. They're undersaturated, and they fall below the line. So for example, what if at 50 degrees, you only added 40 grams of NaNO3? Notice that's way below what it can normally hold, right? It normally can hold 116. 40 is way less. So that would be unsaturated. Supersaturated holds more than they normally could at a certain temperature and falls above the line. So for example, 50 degrees, NaNO3, if you added 100, let me go back a sec. Okay. It normally holds 116, but if you add 140, you're above the line. You made a supersaturated solution. Okay, reference table F tells us which ionic compounds are soluble or insoluble. Try one. Is this soluble or not? Remember, always look up PO4, right? Look up your anion, the negative anion first. You can pause the video. Okay, let's go over. PO4 is usually insoluble. However, Li is a group 1 ion, which is an exception, flipping it to make it soluble. Try another one. Again, start with the anion. Carbonate is insoluble. Ca as a partner is not an exception, so this would be insoluble. It would stay insoluble. Things that are insoluble are precipitates, and they form these cloudy solids. Like dissolves like is another rule that tells us what things dissolve. Polar solutes dissolve in polar solvents, like sugar in water. Nonpolar solutes dissolve in nonpolar solvents, like oil in mineral oil or turpentine. Most ionics, but not all, you can see table F again, dissolve in polar solvents. What happens when something dissolves? Well, it depends. Ionic salts dissociate and break into more ion particles and spread out. So when I put CaCl2, ionic, metal with nonmetals, it becomes its ions, a Ca2 plus and two Cl minuses, three ion particles. Well, if you put a covalent and it dissolves, it doesn't break into ions because there are no ions in a covalent molecule. They just spread out. They don't dissociate. Okay, so what are colligative properties, this new term? Adding a solute to a solvent changes the properties of the solvent, and these are called colligative properties. Colligative properties have to do with how much solute you add. The amount of solute you add affects the freezing point temperature, the boiling point temperature, and the vapor pressure. Colligative properties are based on entropy or disorder. Entropy is how random or messy a system is. If you add more molecules of stuff to a system, it becomes more disordered. The more entropy involved means more interference of particles. And that's what's going to affect the properties. Let's look at freezing point. How does the amount of solute affect the freezing point of the solvent? Well, when I have 0% salt, 100% water, pure water, the freezing point is 0 degrees Celsius. If I add some salt, now the freezing point of that solution goes down to -6. If I add even more salt, the freezing point drops to -16. So if you increase the amount of solute, there's more interference. And let's look at the pictures. Right? If I have here just the water trying to freeze, they can just join together and make a clump of solid ice. But if I have these little salt particles interfering, you have to remove even more energy to force them together. The solvent's freezing point decreases because more energy has to be removed to get the solvent particles to become an organized solid. This is called freezing point depression. So when they put salt on the snowy roads, the salt dissolves into the icy water, the snow, the ice, and interferes with the ability of that water to freeze or stay frozen. This lowers the freezing point of the water, which allows the ice to melt. Salt can do this, but other things too. You could put lots of sugar on the ice, and eventually it would also interfere and melt, but it would be a mess. Okay, boiling also is affected. While 0% salt, 100% pure water boils at 100 degrees Celsius. If I add some salt, the boiling point goes up to 106. If I add more salt, it pushes the boiling point up to 116. So, if you increase the amount of solute, in this case salt, the entropy increases. So let's take a look. Here you have pure water. These little particles of water are trying to become a liquid and go to be a gas, or trying to boil. But if you have salt there, it's interfering with the ability of that water to become a gas. And that interference means the entropy increases, and the solvent's boiling point must go up because it requires more energy for the solvent particles to escape around the solute and become a gas. This is called boiling point elevation. When you put antifreeze in your car, the antifreeze dissolves into the water, and that raises the boiling point of the water, which prevents your car engine from overheating. So not only do you add antifreeze in the winter to prevent your cars from freezing, you put it in the summer to prevent it from overheating as well. And last, vapor pressure. Vapor pressure has to do when you have, in this case, water trying to boil, right, and become a vapor. So you have the pure water here pushing to get out, that's vapor pressure, and the atmosphere is pushing down. What happens when you add little solute particles? Well, they interfere with the ability of the solvent here, the water, to push. So, with the solute added to the water, it's harder for the water molecules to escape and evaporate, and the vapor pressure is reduced. Again, it's all about interference. Okay, feel free to watch this video again and pause whenever you need to take notes. Send any questions my way.